In this video, we're going to learn how to factor polynomials with a degree higher than 2. So example 3 says to use division to verify that x plus 4 is a factor of 2x cubed plus 5x squared minus 14x minus 8 and factor the resulting quotient. So we can go about this two ways. The first way, and honestly the easiest way, to verify that x plus 4 is a factor, we could use the factor theorem and we could plug in -4 into everywhere I see an x and hope that I get a 0, and that would verify that it's a factor. Because I have to factor the resulting quotient, I might as well go ahead and use synthetic division and divide so that I can then factor what's left. So let's use synthetic division then. X minus 4, if you set that equal to 0, you'll subtract your 4 and we'll get x equals -4. So I will put that on the outside. And then I'm going to put my coefficients. And notice that it's not skipping anything. You've got x cubed, x squared, x constant. So I don't have to put a 0 placeholder. So we've got 2, 5, -14, and -8. So use synthetic. Drop down your first one. Multiply, add, multiply, add, multiply, add. Multiply. Add, multiply, add, multiply, add. Okay, so because I get a remainder of 0, this has been verified. So now what I have left here is, remember this is constant x squared. So my polynomial now is 2x squared minus 3x minus 2, and we could do plus 0 over x plus 4, but 0 over anything is 0, and so this is what I have left here. And I need to factor the resulting quotient. So now I've got to factor this. So I look for a GCF. There's not an equation, so you don't have to worry about standard form. So I look for a GCF and I don't have one, so I'm going to go into my x here. My a times c is 2 times -2. My b term is -3, and so I need two numbers that add up to -3 but multiply to -4. I'll give you a minute to think about that. Multiplies to -4, but adds up to a -3. Okay, that's -4 and 1. Now, this is not an easy trinomial, so this is not x minus 4, x plus 1, because x times x is x squared, and I need this to be 2x squared. So because my a is not 1, I have to rewrite my middle term using these two numbers. So this is 2x squared minus 4x plus 1x, or plus x minus 2. If I combine my like terms, I'm right up to my original, so I'm not changing it. I'm, in a way, unsimplifying it. Now that I have 4 terms, I'm going to factor by grouping. My GCF in the first grouping is 2x. When I divide that out, I am left with x minus 2. Here, notice I have the exact same thing. And which is good because I don't have a GCF here, so I'm going to pull out a 1, which makes everything stay as x minus 2. So this factors to 2x plus 1, which is what my GCFs are here, and then x minus 2, which I have here. So to answer this question, to factor this, 2x cubed plus 5x squared minus 14x minus 8 equals x plus 4, and then what we have over here, 2x plus 1 and x minus 2. Okay. Let me line this back up a little bit. Okay. So notice here, my highest degree was 3, and I have 1, 2, 3 factors of this polynomial. I found these two by factoring what was left, but I did divide this out of my polynomial. So they told me one factor, right? They gave me x plus 4 was one factor. So I took this factor and I divided it out. What was left was a quadratic, and we know how to solve quadratics. We solve by factoring quadratic formula or square root property. And so I factored this out to get this. This is going to be sort of the process of factoring these, or if we need to solve, we'll take it one step further and we'll set all these equal to 0 and solve. We're going to find one of these zeros or one of these factors. We'll have to divide it out to get to a squared. And then once we get a squared, we can factor or square root property or quadratic formula. The problem is this one was set up easy for us because it gave us that other factor. That's not always going to happen. In fact, it's rarely going to happen that we're going to be given one of the factors. So on the next page, we have something called rational zeros theorem. And rational zeros theorem is going to help us get to our answer. Okay, it's going to help us in this factoring process. So your zero factor theorem says if you're given a polynomial, the possible rational zeros are in the form of factors of a sub o or a naught over the factors of a sub n. So if you kind of look what we have here, your a naught is in the back, and that's going to go on top, and your a sub n is your leading coefficient. Now, a lot of times we will refer to this as P over Q, which P is your constant and Q is your leading coefficient. So example 4, use the rational zeros theorem to list your potential rational zeros of the polynomial function. Do not attempt to find the zeros. I just want to list the possible rational zeros. So we will do that by finding our factors of P over our factors of Q. My P is in the back. So my factors of 4, I can do 1 times 4 or 2 times 2. Now, when we do this to get to this positive 4, I could do -2 times -2 or +2 times +2. I could do 1 times 4, or I could do -1 times -4. So when I list these, I'm always going to do plus or minus my factors. So this is plus or minus 1, plus or minus 2, and plus or minus 4. All over my factors of Q, which are 3. The only way to get to 3 is 1 times 3, but again, you can do 1 times 3 or -1 times -3 to get to that positive. So this is plus or minus 1 over plus or minus 3. Okay, so now let's start dividing to figure out what we get. I always go all of the top ones divided by one of the bottom ones. I think that's the easiest way. So I'm going to do 1 divided by 1, which is plus or minus 1. 2 divided by 1, which is plus or minus 2. And 4 divided by 1, which is plus or minus 4. So I've divided everything by 1. So now let's divide everything by 3. So 1 divided by 3 is plus or minus 1/3. 2 divided by 3 is plus or minus 2/3. And 4 divided by 3 is plus or minus 4/3. So now I've divided everything by 3. And so here are my potential rational zeros. I have 12 of them. I've got 2, 4, 6, 8, 10, 12. Possible zeros. No, not zeros. I'm sorry. Answers. Okay. I'm not putting zeros because I only have a possible of 3 different zeros. That leading degree tells me I only have at most 3 different zeros. So of those 3 zeros, I've got 12 different possible answers. Okay. Let's do the same thing on B. I'm going to do the factors of P over the factors of Q. My P is 9. So to get to 9, I can do 1 times 9 and 3 times 3. So this is plus or minus 1, plus or minus 3, plus or minus 9. Over. My Q is 6. And that's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So I'm going to divide everything on the top by one thing at a time on the bottom. So 1 divided by 1, plus or minus 1. 3 divided by 1, plus or minus 3. 9 divided by 1 is plus or minus 9. So 1's done. I'm going to move over to 2. 1 divided by 2 is plus or minus 1/2. 3 divided by 2 is plus or minus 3/2. 9 divided by 2 is plus or minus 9/2. So 2 is done. Now divide everything by 3. Be careful here though. We're not going to write down repeated potential rational zeros. 1 divided by 3 is 1/3. But then 3 divided by 3 is 1. I already have that listed. 9 divided by 3 is 3. I already have that listed. So from dividing by 3, I only added 1 more. Be careful with 6 because the same thing happens. 1 divided by 6 is 1/6, and I don't have that yet. 3 divided by 6 is 1/2. I have that. And 9 divided by 6 is 3/2, which I have that as well. So I only added 1 more from my 6 as well. So here are my potential rational zeros. So how many answers do we have in this one? Or how many possible answers do we have? We've got 2, 4, 6, 8, 10, 12, 14, 16 possible answers. But how many zeros does this function have? It's got 4. I was going to keep going, but I think I'm going to stop the video here because it's getting kind of long. Make sure you understand this and you understand example 3 before you move on.